Right now, as you listen to these words, our planet is racing through the cosmic void at a speed of more than 100,000 kilometers per hour. We are hurtling around the sun, which itself flies through the galaxy at a speed of almost 800,000 kilometers per hour. And yet, you feel absolutely nothing. Not the slightest breath of wind, nor a single jolt. Complete silence. But here is what should truly make you freeze for a moment. If a certain observer were only a few light years away from us, say, on the star closest to us, Proxima Centauri, and if they had the most powerful telescope imaginable, they would not see Earth. In fact, our planet would be invisible to them. Not because it is hidden for some reason, not because it is shrouded in some mysterious haze, but because on the scale of the universe, Earth is so small, so dim, so insignificant, that it simply gets lost in the infinite blackness of space, like a speck of dust in a flashlight beam in the middle of the night ocean. And this is only the beginning of the journey we will embark on together today. Because the further we move away from our planet, the more frightening the picture will become. Today, you will learn 3 things that will forever change your perception of humanity's place in the universe. First, why even our sun, this giant glowing star that seems so important and powerful to us, is actually a dwarf among real cosmic monsters? Second, what happens when we try to measure the size of the observable universe and why these figures literally break the human mind? And third, what does this unimaginable infinity of space and time mean for us, for our civilization, for everything we have ever created and dreamed of? When you finish listening to this story, you will never be able to look at the night sky with the same eyes again. Those little lights flickering over your head will take on a completely different meaning. And perhaps this very night will be the beginning for you of a completely new understanding of what it means to be human in this unimaginable universe. If you are fascinated by the mysteries of space, subscribe to the channel. Our journey begins right now. Let's return to childhood for a moment. Remember how you were first told about the solar system. Perhaps it was at school. Perhaps in some book with bright pictures. You were shown a beautiful diagram where the sun was located in the center, and around it the planets Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune were lined up in neat circular orbits. And it all looked so cozy, so orderly, so clear. The sun was a large yellow ball, the planets were smaller, and the distances between them seemed quite manageable. Remember this picture? It still hangs in many classrooms, in many textbooks, and it lies to you. This diagram is one of the largest scale visual deceptions in the history of education. Not because it shows the wrong planets or they are in the wrong order. No, all that is true. The deception lies in the scale, in how the sizes and distances are shown. Because if we tried to draw the solar system at actual scale on an ordinary sheet of paper, something strange would happen. If the sun were the size of a small coin, say, a centimeter in diameter, then the Earth on this diagram would be an invisible point, literally a speck of dust that you could not see with the naked eye. And this speck of dust would be located about a meter from our sun coin. And Neptune, the farthest planet of our system, it would be 30 meters from the sun, 30 meters from a centimeter coin. Imagine this space, imagine this emptiness. And this is where the first realization begins, slowly creeping up on you like the cold of a winter night. The solar system, our cosmic home, our territory in the universe, is not a cozy cluster of planets around a warm star. It is a vast emptiness in which tiny balls of matter are scattered at monstrous distances from each other. The space between the planets is not just large, it is overwhelmingly huge. It is so empty that if you tried to cross the distance from Earth to Mars on foot, you would need to walk continuously, without sleep or rest, for more than 1,000 years. 1,000 years of continuous walking to reach our nearest neighbor. But the reality is much more eerie than just long distances. Imagine that you are in open space somewhere between Earth and Mars. Around you is absolute blackness. Stars do not twinkle as they do on Earth. They burn with a steady, cold light. The sun no longer seems so huge. It has turned into a very bright star, but still a star. And around you is nothing. Absolutely nothing. Not a single atom for millions of kilometers in any direction. You are hanging in such an emptiness that the human mind is not capable of truly comprehending. And in this emptiness, in this infinite nothingness, somewhere far, far behind you, a small blue dot is lost. Earth. Everything you knew. All the people you loved. All of human history. All wars and peace treaties. All books and paintings. All dreams and fears. All of this is concentrated on this tiny speck of dust that is slowly floating away into the blackness. But wait, we haven't even really started moving away yet. We are still within our solar system. We haven't even reached its boundary. And this boundary is much further than you think. You see, when we talk about the solar system, we usually end at Neptune. But that's not true. Beyond Neptune lies the Kuiper Belt, a giant ring of icy bodies and dwarf planets. And beyond the Kuiper Belt lies something even more massive, the Oort cloud, a spherical cloud of billions, perhaps trillions of icy objects that envelops our solar system like a giant cocoon. And the size of this cloud is truly mind-blowing. If the distance from the Earth to the Sun is taken as one astronomical unit, then the outer boundary of the Oort cloud is located approximately 100,000 astronomical units from the Sun. 100,000. For light, the fastest traveler in the universe, to get from the Sun to the edge of the Oort cloud, it would take about 1.5 years. And now imagine this picture. Our solar system, this huge bubble of space, inside which are all the planets, all asteroids, all comets, everything we have ever studied and explored. This bubble is almost 2 light years in diameter. And in the very center of this unimaginable bubble, at a distance of only 8 light minutes from the Sun, hangs the Earth. 8 light minutes. On the scale of our own system, we are practically right next to the Sun. We are literally pressed against it, like frightened children huddled near a campfire in the middle of a dark forest. But even this is not the whole story, because everything I have described now, this entire giant bubble of our solar system, looks completely different on the scale of the galaxy. Are you ready for this? Get ready, because now we will take another step back, and the picture will become even more dizzying. The Milky Way, our galaxy, our cosmic home at the next level of scale. This is a spiral structure consisting of hundreds of billions of stars. The exact number is unknown, but according to various estimates, there are from 100 to 400 billion stars in our galaxy. Each of these stars can potentially have its own planets, its own asteroids, its own comets, its own forms of life. And this entire huge cluster of stars slowly rotates around a common center, making one full revolution in about 250 million years. Now try to imagine the size of this structure. The diameter of the Milky Way is approximately 100,000 light years. It takes 100,000 years for light to cross our galaxy from end to end. Light, which moves at a speed of 300,000 kilometers per second, which in 1 second could go around the Earth almost 8 times. This light needs 100,000 years to simply cross our galaxy. And where is our solar system located in this giant stellar whirlpool? Somewhere on the periphery, in one of the spiral arms called the Orion Arm, not in the center, not in any special place, we are located approximately 26,000 light-years from the center of the galaxy, that is about halfway from the center to the edge, in the cosmic suburbs, if you will, in a quiet, unremarkable area where stars are located not too densely and not too rarely, where nothing special happens, where no one pays special attention to a small yellow star with 8 planets around it. And this is where that very invisibility we talked about at the very beginning starts to manifest itself. Because if you try to find our solar system on an image of the Milky Way, you will not be able to do it. Not because it is hidden or covered by something, but because it is too small. This entire huge bubble of space, 2 light years in diameter with all the planets and the Oort cloud, would be an invisible point on a photograph of the galaxy, one of hundreds of billions of identical points, absolutely indistinguishable, absolutely invisible. One of many. Imagine a beach, a huge beach stretching beyond the horizon in both directions. And on this beach lie billions of grains of sand. And one of these grains of sand is our sun with all its planets. And Earth? Earth is not even a grain of sand. Earth is an atom inside this grain of sand, invisible, indistinguishable, insignificant from the perspective of the beach. But wait, we are not finished yet, because the Milky Way, for all its unimaginable vastness, is just one galaxy, one of many. And when we go beyond the limits of our galaxy, the scales become so absurd that human language begins to stall trying to describe them. Right now, at the moment you are listening to these words, astronomers observe about 2 trillion galaxies in the observable universe. 2 trillion. That is 2 million. If you tried to count galaxies one by one per second without breaks for sleep and food, it would take you more than 60,000 years just to count them. And each of these 2 trillion galaxies contains billions or even trillions of stars. Each of these stars is potentially surrounded by planets. The scale becomes so huge that numbers lose meaning. And the Milky Way, our home with all its hundreds of billions of stars, including our sun, including Earth, including you and me, and all the people who have ever lived, is just one galaxy out of 2 trillion. One grain of sand on a cosmic beach the size of the universe itself. But even this is not the end, because the observable universe, those 93 billion light-years of space that we can theoretically see, is probably only a tiny part of the entire universe. Cosmologists suggest that the full universe may be billions of times larger than the observable one, or it may be infinite. We do not know, and perhaps will never know. And in this context, Earth becomes not just invisible, it becomes something so small, so insignificant on cosmic scales, that our language simply has no words to describe this degree of insignificance. We are not just small, we are so tiny that the very concept of size ceases to work when we try to compare ourselves to the universe. But reality is even more eerie than just a question of size, because there is another aspect of our invisibility that is rarely talked about. And this aspect is related to time. The universe is about 13,800,000,000 years old. This is an age that is so huge that the human mind is not capable of truly comprehending it. But let's try. Imagine that the entire history of the universe is 1 year. 1 calendar year from January 1st to December 31st. On this scale, the Big Bang happened at midnight on January 1st. The Milky Way formed around March. The solar system appeared in September. Life on Earth originated somewhere in late September or early October. Dinosaurs went extinct on December 26th. And the entire history of mankind, from the first Homo sapiens to today, fits into the last few minutes of December 31st. The last minutes of the last day of the cosmic year. We appeared just now. On the scale of the universe, we exist for an instant. The entire human civilization, all empires and revolutions, all discoveries and inventions, all art and all science, all of this happened in the last few seconds of cosmic time. We are so young, so new, that the universe hasn't even had time to notice us, and perhaps will never notice us, because here's the thing. Space is not only huge in space, it is huge in time. And in this infinite stream of time, humanity is a flash. Brief, bright, but a flash. A moment between 2 eternities. And when you begin to truly realize these scales, when numbers and comparisons begin to fold into a single picture, something strange happens. You begin to feel a chill. Not a physical cold, but something else. A feeling that ancient philosophers called cosmic loneliness. A feeling that we are lost in infinity. That we are screaming into the darkness, and the darkness does not answer. that we are invisible not because we are ignored, but because the very concept of our existence is indistinguishable on the scales we are talking about. But it is in this feeling, in this chilling awareness, that something important is hidden, something that can change how you look at the world. And we will talk about this further as we continue our journey into the depths of space, because we have only just begun. We haven't yet talked about how those giant structures in which our galaxy is lost are organized. We haven't yet discussed dark matter and dark energy, which make up most of the universe and about which we know almost nothing. We haven't yet delved into questions about the boundaries of space, about what might lie beyond the observable universe, if there is any beyond at all. And we haven't touched upon the most frightening question of all, the question that logically follows from everything we have already discussed. If the universe is so huge, if there are trillions of galaxies with trillions of planets in it, if there was enough time for life to arise billions of times, where is everyone else? Why don't we see signs of other civilizations? Why is space silent? This question is known as the Fermi paradox, and perhaps the answer to it is even more frightening than the silence itself. But all that is ahead. In the meantime, let these thoughts slowly sink into your consciousness. Allow yourself to feel the scale of what we are talking about. Close your eyes if you want. Imagine yourself on this small blue planet hanging in the void. Around you is the blackness of space, dotted with distant lights of stars. Each of these lights is a sun, perhaps with planets, perhaps with life, but so far away that their light has been traveling to us for years, decades, millennia. Some of these stars have already gone out, but their light is still traveling to us. We see the past by looking at the sky. We are looking at ghosts, and in this ghostly light, our Earth circles its star. One revolution per day, one orbit around the sun per year. Billions of orbits throughout the history of the planet. And we are on it. Random passengers on a random rock in a random corner of a random galaxy. This should not scare you. Or perhaps it should, because in this fear, in this awareness of one's own insignificance, a strange freedom is hidden. The freedom to understand that all our problems, all our anxieties, all our ambitions and fears are ripples on the surface of an infinite ocean. They are real to us. They are important to us. But space does not know about them and will never know. And this is only the first part of our journey. We have barely pushed off from the shore. Ahead are many more discoveries, many amazing facts, many moments that will make you hold your breath. So make yourself comfortable. Relax. Let your thoughts flow freely. And let me continue telling you about why our Earth is invisible on the scale of the universe and what it means for all of us. We stopped at the point that our Milky Way galaxy is only one of 2 trillion galaxies in the observable universe. But now, let's dive deeper. Let's look at what makes our insignificance even more obvious. And we'll start with what is very close to us, with our sun. The sun, the source of all life on Earth, a luminary worshipped by ancient civilizations, a god for Egyptians, Greeks, Incas, and many other peoples. And they can be understood. The sun gives us warmth. The sun gives us light. Without the sun, there would be neither plants nor animals nor you and me on Earth. For us, the sun is everything. It is the center of our world. It is the anchor around which our whole life revolves, and the sun is truly huge by human standards. Its diameter is approximately 1,400,000 kilometers. This is 109 times larger than the diameter of Earth. If the sun were hollow, about 1,300,000 planets the size of Earth would fit inside it. 1,300,000. Imagine this figure. Try to imagine 1,000,000 Earths packed inside one sphere. It's almost impossible. Our mind begins to fail at such scales, and the mass of the sun corresponds to its size. The sun contains 99 and 8/10% of the entire mass of the solar system. everything else, all 8 planets, all dwarf planets, all asteroids, all comets, all dust, and all gas. All of this makes up less than 0.25% of the system's mass. The Sun is practically the entire solar system, and we, Earth, we are just a tiny impurity on the periphery. It would seem that the Sun is incredibly huge and powerful, but here's the catch. In the context of other stars, our Sun is a dwarf. Literally, astronomers classify it as a yellow dwarf. This is not an insult or an understatement. This is an official classification. Our Sun belongs to one of the most common and most modest types of stars in the universe. Let me introduce you to some real giants of the stellar world. And when I say giants, I mean it literally. Let's start with Betelgeuse. This is a red supergiant in the constellation Orion. You can see it with the naked eye. If you go outside at night and find Orion, Betelgeuse will be one of the brightest stars with a characteristic reddish tint. So, the diameter of Betelgeuse is about 1,000 times the diameter of our Sun. 1,000 times. If we placed Betelgeuse in the center of our solar system, it would swallow the orbits of Mercury, Venus, Earth, Mars, and perhaps even Jupiter. Our planet would be inside this star, deep within its glowing depths. But Betelgeuse is not even the largest star we know. There are stars even larger. For example, UY Scuti. This is one of the largest red supergiants known to us. Its diameter is about 1,700 times larger than the solar one. If it were in place of our Sun, its surface would extend far beyond the orbit of Jupiter, perhaps reaching the orbit of Saturn. The entire inner part of our solar system would simply be inside the star. And there is also Stephenson, 2-18. According to some estimates, this is the largest known star in the universe. Its dimensions are so colossal that it takes light about 8 hours to go around its equator. 8 hours for light. For comparison, it takes light about 1 4/10 seconds to go around our Sun. 14 seconds versus 8 hours. Feel this difference. And now think about this. Our Sun, which seemed so huge and powerful to us, which contains 1,000,000 Earths against the background of these cosmic monsters, looks like a pea next to a skyscraper, and this forces us once again to reconsider our place in the universe. We revolve around a dwarf. Our planet is a speck of dust revolving around a dwarf. And this dwarf is lost among hundreds of billions of other stars in our galaxy, many of which are tens, hundreds, and thousands of times larger than it. But the size of a star is not everything. Let's talk about energy, about what forces rage in space. Because when we begin to consider the energy processes of the universe, our insignificance acquires completely new dimensions. Every second, our Sun converts about 600 million tons of hydrogen into helium. 600 million tons every second. At the same time, a small part of the mass is converted into pure energy, according to Einstein's famous formula. The energy that the Sun radiates in 1 second is equivalent to the explosion of several trillion nuclear bombs every second. And so it has been for almost 5 billion years. And so it will continue for about the same amount of time. This is an unimaginable amount of energy. But even this energy is insignificant compared to what is happening in other corners of space. Take, for example, supernova explosions. When a massive star, significantly larger than our Sun, exhausts its nuclear fuel, a catastrophe occurs. The star's core collapses under its own gravity, and the outer layers are ejected into space with monstrous force. This is a supernova explosion, and the energy released in such an explosion exceeds anything you can imagine. In a few seconds, a supernova radiates more energy than our Sun will produce in its entire life. In 10 billion years of existence, a few seconds versus 10 billion years. A supernova at the moment of explosion can shine brighter than the entire galaxy in which it is located. One star temporarily surpasses hundreds of billions of other stars combined in brightness, and such explosions happen in the universe constantly. In our Milky Way, a supernova flashes about once every 50 years. On the scale of the entire observable universe, supernovas explode every second. Every second, somewhere in the universe, a star dies, throwing out into space energy equivalent to trillions of nuclear bombs. But even this is not the limit. There are phenomena that eclipse even supernovas. They are called gamma-ray bursts. These are the most powerful explosions in the universe after the Big Bang. A gamma-ray burst occurs when the core of an especially massive star collapses into a black hole, or when two neutron stars merge. At the same time, such an amount of energy is released that it literally does not fit in the head. In a few seconds, a gamma-ray burst can radiate more energy than our sun will produce in its entire existence, multiplied by 1,000,000. This is not an exaggeration. These are real calculations by astrophysicists. And these gamma-ray bursts can be observed from a distance of billions of light years. They are so bright that we see them at the other end of the observable universe. If a gamma-ray burst occurred close enough to Earth, say, within a few thousand light years, it could destroy all life on our planet, not by physical impact. Gamma rays would simply sterilize the surface of the Earth, destroy the ozone layer, change the chemistry of the atmosphere. Everything alive on the illuminated side of the planet would perish instantly, and the rest would die out in the following months and years. And the creepiest thing in this scenario is that we would not see its approach. Gamma rays move at the speed of light. We would find out about the gamma ray burst at the same moment it killed us. No warning, no possibility of escape, just an instantaneous end. But one shouldn't worry too much. The probability that a gamma-ray burst will occur close enough to us and be pointed in our direction is extremely small, although, of course, not equal to zero. Space is full of dangers that we don't even think about, and most of these dangers are invisible and unpredictable. Now let's talk about black holes. Because if we are discussing the invisibility of Earth and the insignificance of humanity, we cannot ignore these objects. Black holes are perhaps the strangest and most frightening objects in the universe. A black hole is a region of space where gravity is so strong that nothing can leave it, not even light. That is why they are called black. They do not emit any light. They absorb everything that approaches them. The boundary of a black hole is called the event horizon. This is the point of no return. Everything that crosses the event horizon is lost forever. No information, no matter, no signal can get out. And black holes come in different sizes. There are so-called stellar black holes, which form during the collapse of massive stars. Their mass is from several to several tens of solar masses, and the size of the event horizon can be only a few tens of kilometers. Imagine a mass 10 times larger than the solar one, compressed into a sphere the diameter of a small city. The density of such an object is unimaginable, but there are black holes much larger, supermassive black holes. They are located in the centers of most galaxies, including ours. In the center of the Milky Way is a supermassive black hole called Sagittarius A star. Its mass is approximately 4 million solar masses, 4 million suns concentrated in one point. The event horizon of this black hole is about 20 times larger than the diameter of our sun. And this black hole is always there, in the center of our galaxy, about 26,000 light-years from us. It slowly absorbs matter. Stars and gas clouds whirl around it in a mad dance. Some of them fall inside and disappear forever. And we on our small planet do not even notice it. For us, it is too far. Too abstract, too unreal. But Sagittarius A star is not even the largest black hole we know. There are black holes with a mass of billions and even tens of billions of solar masses. For example, the black hole in the center of the galaxy Messier 87, the image of which was obtained in 2019, has a mass of about 6.5 billion suns. Its event horizon is larger than our entire solar system. The entire system, whole, including the orbit of Neptune, and even part of the Kuiper Belt, would fit inside this black hole. Imagine this: an object the size of our solar system, but so dense that even light cannot leave it. An object that distorts space and time around itself so strongly that the usual laws of physics cease to work. An object that absorbs everything that approaches it, and from which nothing ever returns. And such objects are scattered throughout the universe. There are billions, perhaps trillions of them, and each of them is a reminder of how extreme and alien space can be, how far it is from our everyday experience, how unadapted we are to its reality. But let's turn away from individual objects and look at the structure of the universe as a whole, because when we start to consider space on the largest scales, the picture becomes even stranger and more mesmerizing. Galaxies are not scattered across the universe randomly. They form structures, groups, and clusters. Our Milky Way is part of the so-called local group of galaxies. This is a small cluster numbering about 50 galaxies. The largest of them are the Milky Way, the Andromeda Galaxy, and the Triangulum Galaxy. The rest are significantly smaller. Many of them are dwarf satellite galaxies that revolve around larger neighbors. The local group has a diameter of about 10 million light-years. This is a huge distance, but it is only a small block in a cosmic city. The local group is part of a larger structure called the Virgo supercluster. This is a giant association of galaxies and their clusters that extends for about 110 million light-years and contains about 100 groups and clusters of galaxies. But even the Virgo supercluster is only a small part of an even more grandiose structure. In 2014, astronomers determined that we are part of a colossal galactic supercluster, which they called Laniakea. This word means immense heavens in the Hawaiian language, and the name is quite justified. Laniakea extends for about 500 million light-years and contains about 100,000 galaxies. 500 million light-years, 100,000 galaxies. And somewhere in this unimaginable volume of space, in one of the insignificant corners, is the local group, and in it the Milky Way, and in it our solar system, and in it Earth, and on it you and I, trying to comprehend all this. But the structure of the universe does not end there. Laniakea is part of an even larger structure, larger and larger. Superclusters of galaxies form filaments and walls, between which are located giant voids. This entire system resembles a giant three-dimensional web or sponge. Astronomers call it the cosmic network, or cosmic web. The cosmic web is the largest known structure in the universe. It permeates the entire observable space. The filaments of this web, consisting of galaxies and dark matter, can extend for billions of light-years, and between them lie voids. Huge regions of almost complete emptiness, where there are almost no galaxies, no stars, no planets. Some of these voids have a diameter of hundreds of millions of light-years. Imagine hundreds of millions of light-years of absolute emptiness. Nothing, just darkness and vacuum. And here we return again to the main theme of our conversation, to the invisibility of Earth. Because against the background of all these structures, against the background of voids and filaments, against the background of superclusters and clusters, against the background of billions and trillions of galaxies, our planet is not just invisible, it is indistinguishable even as a concept. It exists on scales so small that the very idea of its separate existence loses meaning. It's as if you tried to find a specific atom in a specific grain of sand on a specific beach of a planet that revolves around a star at the other end of the galaxy. Technically, this atom exists, but practically it is indistinguishable, unreachable, and insignificant for any observer at our level of perception. And this leads us to a question that inevitably arises when you begin to truly realize these scales. The question of our place, our meaning, of whether everything we do, think, and feel has any sense at all. If the universe is so huge and indifferent, if we are so small and insignificant, then what is the point? Why all this? This is an existential question, and there is no simple answer to it. But we will return to it later. In the meantime, Let me tell you about another aspect of our insignificance, an aspect that is perhaps the strangest and most disturbing of all. This is the question of dark matter and dark energy, of what the universe is actually made of, and of how little we understand about the world in which we live. Everything we have talked about so far, all these stars and galaxies, all these superclusters and cosmic webs, all these black holes and supernova explosions, all of this makes up only a small part of the universe. And when I say small, I mean it literally. All ordinary matter, everything we can see, measure, study, and understand, makes up less than 5% of the total content of the universe. Less than 5%. This means that more than 95% of the universe consists of something we do not understand, something we cannot see, something we cannot even truly study. Let this thought settle for a moment. We live in a universe, most of which we do not understand. We do not know what it consists of. We do not know how it works. We can only observe its effects and build theories. But the very essence of these 95% remains a complete mystery to us. These mysterious components are called dark matter and dark energy. And despite the fact that they make up the overwhelming majority of the universe, we know strikingly little about them. Let's figure out what they are and why this is so important for understanding our place in space. Let's start with dark matter. Its existence was first spoken of back in the 30s of the 20th century. Astronomer Fritz Zwicky studied a cluster of galaxies in the constellation Coma Berenices and discovered a strange anomaly. Galaxies in this cluster moved too fast, much faster than they should have moved based on the visible mass of the cluster. According to all calculations, they should have scattered in different directions. The gravity of visible matter was not enough to hold them together, but they did not scatter. They remained bound in a single system. Zwicky suggested that there must be some invisible matter in the cluster that creates additional gravity. He called it dark matter. At that time, many scientists were skeptical of this idea, but in the following decades, more and more evidence accumulated in its favor. In the 70s, astronomer Vera Rubin studied the rotation of spiral galaxies and discovered the same problem. The outer regions of galaxies rotated too fast. Stars on the periphery should have broken off and flown away into intergalactic space. But this did not happen. Something invisible held them in place. Today we know that dark matter makes up approximately 27% of all the content of the universe. It is 5 times greater than ordinary matter by mass, and it literally permeates all space. Dark matter forms giant halos around galaxies. It serves as a kind of frame on which the cosmic web rests. Without it, galaxies could not exist in the form in which we observe them. Without it, the entire structure of the universe would be completely different. And here's what's truly eerie. We don't know what dark matter is. We know it's there. We can measure its gravitational influence. We can build maps of its distribution in the universe. But we don't know what it consists of. These are not ordinary atoms. Not protons, nor neutrons, nor electrons. It is something completely different. Something that does not interact with electromagnetic radiation. Something that passes through ordinary matter like a ghost through a wall. Right now, while you are listening to these words, dark matter particles are passing through your body. Millions, perhaps billions of particles every second. You don't feel them. You don't see them. They do not interact with the atoms of your body. They just pass through and fly further. You are literally submerged in an ocean of invisible matter that you don't even suspect. Scientists have built giant detectors deep underground, hoping to catch at least one particle of dark matter. They use supersensitive devices that are capable of recording even the weakest interaction. But so far there have been no direct detections. Dark matter remains elusive. It's like a shadow you see out of the corner of your eye, but which disappears when you turn to look. There are many theories about what dark matter might represent. Some scientists believe these are unknown elementary particles, so-called WIMPs or axions. Others suggest these are primordial black holes formed in the first moments after the Big Bang. Still others think it is a manifestation of some modified gravity that we do not yet understand. But the truth is that we don't know. Almost 100 years after Zwicky's first assumptions, we still do not understand what most of the matter in the universe consists of. And that's just dark matter. There is also dark energy, and it is even more mysterious. Dark energy was discovered in 1998. Two independent groups of astronomers studied distant Type 1a supernovas. These supernovas are used as standard candles for measuring cosmic distances because they always have approximately the same luminosity. By measuring their visible brightness, one can determine how far away they are. Astronomers expected to find that the expansion of the universe is slowing down. This would be logical. Gravity pulls matter towards each other, so the expansion should gradually decelerate. But they discovered the exact opposite. The expansion of the universe is accelerating. Over time, galaxies fly away from each other faster and faster. This was a shocking discovery. It contradicted all expectations. Something was pushing the universe apart from the inside. Something was counteracting gravity. Something was making space expand with acceleration. This something was called dark energy. And dark energy makes up approximately 68% of all the content of the universe. 68% is more than everything else combined. Dark energy dominates in the universe. It determines its fate, and we have no idea what it is. Some physicists believe that dark energy is a property of space itself. Einstein, in his equations of general relativity, introduced the so-called cosmological constant, which describes vacuum energy. Perhaps dark energy is a manifestation of this vacuum energy. But when physicists try to calculate what this energy should be, they get a number that differs from the observed value by 120 orders of magnitude. 120 orders of magnitude. This is the largest discrepancy between theory and experiment in the history of science. We fundamentally don't understand something. Other scientists suggest that dark energy is some dynamic field permeating the universe. They call it quintessence. Well, even this theory has not yet received experimental confirmation. Now think about this. We live in a universe that is 95% composed of something we do not understand. We call it dark matter and dark energy, but these names are just labels for our ignorance. We don't know what it is. We don't know where it came from. We don't know how it works. We only know that it exists and that it determines the fate of the entire universe. And in this context, our insignificance acquires a new shade. We are not just small in space. We are not just short-lived in time. We are also blind to most of reality. We see only 5% of what exists. The other 95% are hidden from us. We are like people trying to understand the ocean by studying only a thin film of foam on its surface. Let's now talk about boundaries, about what we know and what we don't know about the size of the universe, because here the story becomes even stranger. The observable universe is that part of space from which light has managed to reach us in 13,800,000,000 years since the Big Bang. Its diameter is approximately 93 billion light-years. Wait, you might say, if the universe is 13,800,000,000 years old, how can its diameter be 93 billion light-years? Couldn't light have traveled a maximum of 13,800,000,000 light-years? This is a good question, and the answer is related to the expansion of space. The point is that while light traveled to us, space itself was expanding. Galaxies that emitted this light billions of years ago have moved even further away during this time. Therefore, the observable universe is much larger than one might expect based on its age. 93 billion light-years in diameter. This distance is so huge that it loses all meaning. But here's what's important to understand. This is only the observable universe, only that part of it that we can, in principle, see. What lies beyond the limits of the observable universe? We don't know, and perhaps we'll never know. Light from objects beyond the observable universe hasn't managed to reach us yet, and due to the accelerating expansion of space, it might never reach us. There are galaxies that are moving away from us faster than the speed of light. Not because they are moving so fast through space, but because space itself between us and them is expanding at such a speed. Light from these galaxies will never reach Earth. They are forever hidden from us. They exist, but for us, they are as if they are not. And here arises a truly dizzying question. How large is the full universe? Not the observable one, but all of it. The answer may be shocking. Many cosmologists believe that the full universe is infinite, not just very large. Infinite, without edges, without boundaries, stretching in all directions, without end. If this is true, then our observable universe is only a tiny bubble in an infinite ocean of space. And in this infinite ocean, everything you can imagine can exist. An infinite number of galaxies, an infinite number of stars, an infinite number of planets, perhaps even an infinite number of copies of you reading these same words at this same moment on other planets indistinguishable from Earth. This is not science fiction. This is a consequence of the theory of an infinite universe. If space is infinite, if matter in it is distributed more or less evenly, then any configuration of atoms, including you and me, must repeat an infinite number of times. This is called the cosmological principle of repetition. And although we cannot test this hypothesis, it mathematically follows from accepted cosmological models. But even if the universe is not infinite, it might be so huge that the difference practically doesn't matter. Some estimates, based on measurements of space curvature, suggest that the full universe might be at least 250 times larger than the observable one, and it might be trillions of times larger. We just don't know. And this returns us to the central theme of our conversation, to the invisibility of Earth. Because if the observable universe is 93 billion light-years of space filled with 2 trillion galaxies, if it's only a tiny part of the full universe, then where in this picture is Earth? Where are we? The answer is simple. Nowhere. We are so small and so far from everything else that the very concept of our presence loses meaning on these scales. We are invisible not because we are hard to notice. We are invisible because on the scales of the universe, concepts such as notice or see are simply not applicable to objects of our size. It's as if an ant were asking if the ocean sees it. The question makes no sense. The ocean does not see, the ocean does not notice. The ocean just is. And the ant in it either drowns or survives. No, the ocean is indifferent to this. Likewise, the universe. It doesn't notice us not because we are not interesting to it. It simply doesn't possess the ability to notice. It just is. Huge, indifferent, infinite. And this leads us to the next question, which is perhaps the most disturbing of all. If the universe is so huge, if there are trillions of galaxies in it with trillions of planets, if there was more than enough time for life to arise, where is everyone else? Why don't we see signs of other civilizations? Why is space silent? This question is known as the Fermi paradox, and its meaning goes far beyond simple scientific curiosity, because the answer to it can tell us something very important about our place in the universe, about our future, about our fate. The paradox is formulated simply: if life arises easily, and if it had enough time to spread through the galaxy, then why don't we see its traces? Our galaxy has existed for about 13 billion years. This time is enough for a civilization that developed even a few million years earlier than us to colonize the entire galaxy, even at speeds that are only fractions of a percent of the speed of light. Why didn't this happen? Why don't we see traces of these civilizations? There are many possible answers to this question, and most of them are discouraging. Perhaps life arises much less frequently than we think. Maybe the transition from chemistry to biology is an event so unlikely that it happens once per galaxy or less. Maybe we truly are alone in the Milky Way, or even in the observable universe. Perhaps life arises often, but intelligent life is a rarity. Maybe evolution does not strive for intelligence. Maybe most living planets are inhabited by bacteria and plants, but not by beings capable of building a telescope or a radio transmitter. Perhaps intelligent civilizations appear, but quickly destroy themselves. Nuclear wars, environmental disasters, pandemics, artificial intelligence gone out of control. Maybe a technological civilization is an unstable state that inevitably leads to self-destruction. Or maybe there is something else, something we don't understand. Some researchers call it the Great Filter, a certain barrier that prevents the development of life to cosmically significant scales. And the most frightening question is where this filter is located, behind us or ahead. If the Great Filter is behind us, it means that we have already passed through the most difficult part, that the emergence of life or intelligence is an event so rare that we are one of the few or the only ones who have overcome it. This would be good news in some sense. But if the Great Filter is ahead of us, it means that something awaits us that destroys all civilizations that have reached our level of development. Something that we don't see yet, but which will inevitably come. And this would be very bad news. We don't know the answer. We don't know if we are alone or not. We don't know if a great future among the stars awaits us or a swift end. We just don't know. This not knowing, this uncertainty, this is the silence of space. This is perhaps the most frightening aspect of our invisibility. We scream into the void, and the void does not answer. The silence of space. This phrase sounds almost poetic, but behind it lies one of the deepest mysteries of modern science. We have been listening to the sky for more than 60 years. Since 1960, when astronomer Frank Drake pointed a radio telescope at the star Tau Ceti as part of Project Ozma, we have been continuously searching for signals from extraterrestrial civilizations. We built giant antennas. We developed complex algorithms for analyzing radio noise. We listened to millions of stars, and the result is always the same. Silence. Of course, one can argue that 60 years is nothing on cosmic scales, that we listen to only a tiny fraction of stars in our galaxy, that alien signals might use technologies we haven't invented yet. All this is true, but it doesn't remove the main question. If intelligent life is widespread in the universe, why don't we see any traces of it? Not just radio signals, nothing at all. No megastructures around stars, no altered atmospheres on exoplanets, no traces of space travel, nothing. And this silence tells us something important about our place in the universe. It emphasizes our isolation, our separateness. We are not just invisible to the universe, we seem to be alone in it, at least in that part of it that we can observe. But let's take a step back and look at it from the other side. Let's imagine that somewhere out there in the depths of space, another civilization really does exist. Let's say they developed on a planet orbiting a star in the Andromeda Galaxy. This is the closest large galaxy to us, located about 2.5 million light-years from the Milky Way. Could they see us? Could they learn about our existence? The answer is unambiguous: no. And the reason is not just the distance, although it itself is colossal. The reason is that we emit practically nothing into space. Yes, humanity began emitting radio waves in the early 20th century. The first radio broadcasts, television signals, radar pulses. All of this travels through space at the speed of light. By now, our signals form a sphere about 200 light-years in diameter with Earth at the center. This means that any civilization within 100 light-years of us could theoretically detect our transmissions. But here's the problem. These signals are incredibly weak. They were not intended for interstellar communication. They were intended for transmitting information on Earth. And as they move away from our planet, they scatter and weaken. At a distance of only a few light-years, they become indistinguishable from background cosmic noise. To detect them, an alien civilization would need to have an antenna the size of a small planet pointed exactly in our direction and know exactly what to look for. And what about light? Earth reflects sunlight, and this light travels through space. But Earth is a tiny dot next to the bright sun. From a distance of a few light years, our planet would be completely lost in the solar glow. Even with the most advanced telescopes imaginable, detecting Earth at such a distance would be almost impossible. We have only recently learned to find exoplanets around other stars. And most of them we detect by indirect methods, by their influence on the parent star, and not directly. Now imagine that you are in the Andromeda Galaxy, 2.5 million light-years from Earth. From such a distance, the entire Milky Way is just a blurry spot of light in the night sky. You cannot distinguish individual stars. You cannot see our solar system. You cannot even determine in what part of the galaxy our sun is located. Earth on this scale is not just invisible. The very concept of Earth loses meaning. It's like trying to see an individual atom in a grain of sand on a beach while being on another continent. And this, perhaps, is the most accurate description of our invisibility. We are not just small. We are so small that even the concept of our separate existence is indistinguishable on cosmic scales. We blend into the background. We dissolve into infinity. But let me tell you something else about space. Something that is rarely discussed in popular science programs. Space is not just empty space dotted with stars and galaxies. Space is an arena of unimaginable violence. An arena where catastrophes of such scale are played out that the human mind refuses to perceive them. We have already talked about supernovas and gamma-ray bursts, but that's just the tip of the iceberg. In the universe, events constantly occur that destroy entire worlds, entire star systems, perhaps entire civilizations, if they exist. Take, for example, the collision of galaxies. This might seem like something distant and abstract, but it is the reality of our cosmic future. In about 4.5 billion years, the Andromeda Galaxy will collide with the Milky Way. Two spiral galaxies, each of which contains hundreds of billions of stars, will crash into each other and begin to merge into one giant structure. The collision itself will last hundreds of millions of years. Stars will be mixed, planetary orbits will be disrupted, gravitational tidal forces will tear star systems apart. Gas clouds will be compressed, giving birth to flashes of star formation. The central black holes of both galaxies will eventually merge, releasing energy equivalent to the mass of millions of suns. And what will happen to Earth, we don't know. Perhaps our solar system will be thrown into intergalactic space. Perhaps it will remain inside the new combined galaxy, but in a completely different orbit. Perhaps some passing star will disrupt the fragile balance of our planetary system, and Earth will be thrown out of the habitable zone. We simply cannot predict this with sufficient accuracy. Of course, by that time, humanity will likely no longer be on Earth. Either we will have settled in other star systems or died out long before that. But the very fact that entire galaxies can collide and destroy each other reminds us of how fragile our existence is, how accidental our well-being is, how temporary our place in this cosmic chaos is. And this is not the only threat. There are asteroids and comets that can collide with Earth. We saw what happened to the dinosaurs 66 million years ago. An asteroid about 10 kilometers in diameter hit the Yucatan Peninsula and caused a mass extinction. 75% of all species disappeared. Dinosaurs, which dominated Earth for more than 160 million years, were wiped off the face of the planet almost instantly in geological terms. And such collisions are not a rarity in Earth's history. They happened before, they will happen again. The question is only when. We have learned to track most large asteroids whose orbits cross Earth's orbit, but small objects with a diameter of 100 or 200 meters can still catch us by surprise. And even such a relatively small asteroid can destroy a city or cause a regional disaster. And then there are threats we don't even think about. A close gamma-ray burst that could sterilize the surface of Earth. a flash from a nearby star that could damage the ozone layer, a wandering black hole that could pass through our solar system and destabilize the orbits of planets. The probability of each of these events is extremely small, but it is not equal to zero, and over long enough periods of time, even unlikely events become inevitable. Space is not hostile to us. That would be too human a characteristic. Space is simply indifferent. It does not care about our existence. It does not notice us. It simply functions according to its laws. And if these laws lead to our death, space does not care. We are no more important to the universe than a speck of dust to a hurricane. And this awareness, this understanding of our absolute insignificance on cosmic scales, can evoke different reactions. For some people, it is a source of horror, existential fear of the meaninglessness of existence. For others, it is strangely liberating. If nothing matters on cosmic scales, then we are free to give meaning to what we want. We are free to create our own meaning. But there is another aspect of our situation worth talking about. An aspect that connects us with space much more intimately than it might seem at first glance. This aspect is related to what we are made of. Have you ever wondered where the atoms that make up your body came from? The carbon in your cells, the calcium in your bones, the iron in your blood. Where did all this come from? The answer is startling. All of this was created inside stars. Every atom heavier than hydrogen and helium was forged in the thermonuclear furnaces of stellar cores or in the cataclysms of supernovas. When massive stars explode, they scatter these elements through space. These elements gather in gas clouds. The clouds compress and form new stars and planets. And eventually, on some of these planets, these elements fold into complex molecules, into cells, into organisms, into you. We are literally made of stardust. This is not a metaphor. It is a physical fact. The carbon atoms in your body were once in the core of a star that exploded billions of years ago. The oxygen atoms you breathe went through the same path. We are the cosmos that has become aware of itself. We are the way the universe looks at itself and wonders about its nature. This is an amazing thought, if you allow yourself to truly feel it. We are not separate from the universe, we are part of it. We are woven from the same substance as the stars. We obey the same laws of physics. We arose from the same Big Bang that birthed everything else. In a sense, when we look at the stars, we are looking at our distant relatives, at our origins, at our essence. And here an interesting paradox arises. On the one hand, we are unimaginably small and insignificant on the scale of space. On the other hand, we are part of this cosmos. We are not external observers looking in from the outside. We are inside. We are part of the process, part of the story that has been unfolding for almost 14 billion years. Maybe our insignificance is not a curse, but a gift. Maybe awareness of our place in the universe is not a source of despair, but a source of humility and awe. We are tiny creatures on a tiny planet in a tiny corner of vast space. And yet we are capable of being aware of this cosmos. We are capable of studying it. We are capable of asking questions about its origin and fate. This in itself is a miracle. Think about it. Of all the matter in the universe, of all these quintillions of tons of gas and dust, only a tiny fraction has folded into structures capable of self-awareness. We are a rarity. We are an anomaly. We are something special, even if we are not special in the eyes of the universe, because the universe has no eyes. But let's return to our journey. Let's continue moving away from Earth and see what awaits us on the furthest frontiers of the observable universe, because there, at the edge of what we can see, even more amazing secrets are revealed. When we look at the most distant objects in the universe, we are looking into the past. Light from these objects has been traveling to us for billions of years. We see them as they were long ago and not as they are now. This is a kind of time machine. A telescope pointed into deep space is a window into the past. the most distant galaxies we can observe are at a distance of more than 13 billion light-years. Light from them began its journey when the universe was less than 1 billion years old. These were young, chaotic, active galaxies. They formed, collided, merged. In them, the first generations of stars were born. We see the universe in its infancy, and if we look even further, if we try to look beyond these first galaxies, we will hit a wall, literally. This wall is called the cosmic microwave background radiation. This is light that was emitted approximately 380,000 years after the Big Bang, when the universe first became transparent to light. Until that moment, the universe was filled with hot plasma that scattered light like fog scatters headlight beams. But when the plasma cooled and atoms first formed, light could propagate freely. The cosmic microwave background is the echo of the Big Bang. This is the oldest light in the universe, and it comes to us from all directions. Wherever we look, we see this radiation. It surrounds us. It fills all space. It is like a wall beyond which we cannot look, and the temperature of this radiation is surprisingly uniform, about 2 7/10 degrees above absolute zero, almost the same in all directions. This uniformity tells us that the early universe was almost perfectly smooth, almost perfectly even, but not quite. There are tiny fluctuations, differences in temperature on the order of 100,000th of a degree. And these fluctuations are the seeds of all structures we see today. These are the embryos of galaxies and clusters. This is the beginning of everything. When you look at the map of the cosmic microwave background, you are looking at a photograph of the infant universe, at a snapshot of how it all began. And somewhere in this picture, in one of these tiny fluctuations, the future of our galaxy, our solar system, our planet, you and me, is embedded. We are the consequences of quantum fluctuations in the first moments after the Big Bang, random fluctuations in density that over time grew into galaxies and stars. Our existence is the result of a chain of events that began almost 14 billion years ago. And this chain could have gone differently. If the fluctuations had been slightly different, we would not be here. There would be no Earth, no Sun, no Milky Way. We are an accident, a cosmic accident, but an accident that is aware of itself, an accident that asks questions, an accident that seeks meaning. And this leads us to the last, deepest question, the question that people have asked since they first looked at the stars. Why all this? What is the meaning in the universe? What is the meaning in us? Science cannot answer this question. Science describes how the world is organized. It doesn't say why it is organized exactly this way. Maybe there is no answer at all. Maybe the universe has no meaning in the sense we put into this word. Maybe meaning is a human invention that we overlay on an indifferent reality. No, maybe that is our role. Maybe we are beings who create meaning. Maybe that is our uniqueness. Not in our size, not in our strength, not in our lifespan, but in our ability to give meaning to things, to love, to dream, to create, to ask questions. The universe is huge and indifferent, but we are not. We are small, fragile, temporary, but we are capable of kindness, of beauty, of understanding. And maybe that is all we need. Maybe this is all, and part of the answer we are looking for. We have come a long way together, from a small blue dot lost in cosmic blackness to the furthest boundaries of the observable universe, from scales we can understand to scales that break our imagination. And now, as we approach the end of our journey, it's time to gather all these disparate threads together. It's time to think about what all this means for us, for humanity, for each of us individually. Let's start with a simple fact that we established at the very beginning. Earth is invisible on the scale of the universe. This is not an exaggeration or a metaphor. This is a literal truth. Our planet is so small, so dim, so lost in the vast expanses of space that detecting it from a distance of even a few tens of light years would be almost impossible, and the universe extends for tens of billions of light years in all directions. We are a speck in a desert the size of a galaxy. We are an atom in an ocean the size of the universe, and this invisibility has several dimensions. We are invisible in space because our dimensions are insignificant compared to cosmic structures. We are invisible in time because the entire history of mankind is an instant in the 14 billion-year history of the cosmos. We are invisible in the composition of the universe because all ordinary matter from which we are made constitutes less than 5% of its content. Wherever we look, whatever aspect we consider, the answer is the same. We are indistinguishable. We are not essential. We are lost in infinity. But here's the strange thing. Awareness of this invisibility does not diminish us. On the contrary, it strangely elevates us, because we are the only ones capable of realizing it. We are the only ones who look at the universe and wonder about our place in it. Stars don't know they are stars. Galaxies don't reflect on their size. Black holes don't experience an existential crisis. Only we. Only these tiny clusters of atoms on a tiny planet by a tiny star. Only we are capable of understanding how small we are. And in this understanding, there is something amazing. The universe existed for almost 14 billion years before someone appeared who could think about it. 14 billion years of blind, unconscious existence. Galaxies formed and were destroyed. Stars were born and died. Planets circled their suns. And no one observed this. No one admired the beauty of a nebula. No one wondered at the majesty of superclusters. No one asked the question, why? And then on one small planet, in an unremarkable corner of an unremarkable galaxy, something unusual happened. Matter organized itself in such a way that it became capable of awareness. Beings appeared who could look at the stars and understand what they saw. Beings who could ask questions and seek answers. Beings who could feel awe at the scale of space and horror at its indifference. We are the eyes of the universe. We are its consciousness. We are the way the cosmos knows itself. And though these eyes are tiny, though this consciousness is fragile, though this knowledge is incomplete, it exists. We exist. And this in itself is a miracle that cannot be overestimated. Think about it again. Of all the matter in the universe, of all these trillions, trillions of tons of substance, only a vanishingly small fraction folded into structures capable of thinking. As far as we know, we might be the only such structures in the entire observable universe, or one of very few. We don't know. But even if we are not alone, even if out there are other intelligent beings, this does not diminish the uniqueness of each of us. Each person is a unique combination of atoms that has never existed before and will never exist again. Each of us is a cosmic event, brief, fleeting, but real. And here we come to the central paradox of our existence. We are simultaneously nothing and everything. We are nothing on the scale of the universe, our bodies, our cities, our planet. All of this is indistinguishable in the cosmic abyss. But we are everything on the scale of our own experience, our joy and sorrow, our dreams and fears, our relationships and achievements. All of this is absolutely real for us. All of this has meaning. Maybe not for the universe, but for us. And maybe that is enough. Maybe we don't need cosmic meaning. Maybe human meaning is enough for us. Meaning that we give to things ourselves. Meaning that we create by our actions, our choice, our love. Philosophers call this existentialism, the idea that meaning is not given in advance but is created by us. The universe doesn't tell us why to live. We must decide this ourselves. And in this, there is great freedom. The freedom to choose your path, the freedom to define your values, the freedom to be who we want to be. But there is another side to this freedom. It requires responsibility from us. If meaning is not given, if the universe is indifferent, if we are alone in our decisions, then we and only we bear responsibility for the consequences. We cannot shift it onto God, onto fate, onto cosmic order. Everything depends on us. And this returns us to the question of our place in the universe. Yes, we are invisible. Yes, we are insignificant. Yes, space does not know of our existence and does not care about our fate. But this doesn't mean our fate is predetermined. This doesn't mean we are powerless. On the contrary, it means everything is in our hands. The future of humanity depends on us, on our decisions, on our choice. We can destroy ourselves. This possibility is real. Nuclear weapons, climate change, pandemics, artificial intelligence. There are many paths that can lead to our extinction. And if we go extinct, the universe will not notice. It will continue to exist as it existed for billions of years before us. Stars will burn, galaxies will spin, black holes will absorb matter. Everything will continue as if we had never been. But we can also survive. We can spread beyond the limits of Earth. We can colonize other planets. We can send ships to other stars. We can become an interstellar and then an intergalactic civilization. This is not fiction. This is a possible future, distant, difficult, but possible. And if we do this, if we spread through the galaxy and beyond, we will cease to be invisible. We will become noticeable. We will become a force to be reckoned with. We will become part of cosmic history, and not just its byproduct. But this is a path of thousands and millions of years. And what about now? What about you and me? What does all this mean for our everyday life? It seems to me that awareness of our cosmic insignificance can free us from many things we consider important, but which are actually not. Petty quarrels and grievances, the pursuit of status and material goods, fear of what others will think. All of this loses its weight when you truly understand how short our life is and how huge the world around is. On the other hand, there are things that acquire additional meaning: love for loved ones, the beauty of nature, the joy of learning, the feeling of connection with something greater than yourself. These simple but deep experiences become even more valuable when you realize how fragile and fleeting they are. We live on a thin line between the infinity of space and the brevity of human life, between the grandiosity of the universe and the intimacy of personal experience. And this line is all we have. It is our home. It is our reality. It is our only opportunity to exist. And you know what I think? I think it's beautiful. Not despite our insignificance, but because of it. Because it is awareness of our smallness that allows us to truly appreciate what we have. Every sunset becomes more beautiful when you know it's the result of a unique combination of atmosphere, light, and your own consciousness. Every conversation with a loved one becomes more valuable when you realize how incredible it is that two clouds of atoms can meet in infinity and understand each other. Every moment of life becomes deeper when you realize that this is a moment in the 14-billion-year history of space. We are temporary, we are fragile, we are invisible, but we are here, right now, at this very moment. You are listening to these words. Your heart beats. Your lungs fill with air, your brain processes information, turning sound waves into thoughts and images. This is a miracle. This is an incredible, inexplicable, staggering miracle, and it is happening right now. The universe does not know about you, but you know about it. You can look at the stars and understand that these are distant suns. You can think about galaxies and imagine their endless spirals. You can reflect on black holes and dark matter, on the Big Bang and the expansion of space. You can ask questions to which there are no answers. You can feel awe and fear, wonder and humility. You can be part of this unimaginable story, even if your role in it is small. And when you look at the sky tonight, if the sky is clear, you will see the same stars that our distant ancestors saw, the same lights that inspired myths and legends, discoveries and travels. You will be looking into the past because the light from these stars has been traveling to you for years and decades. You will be looking into infinity because behind the visible stars are billions of invisible ones. You will be looking at your origin because the atoms in your body were once part of stars like these. And in this moment, standing on a small planet under a vast sky, you will be able to feel a connection with everything that was and will be, a connection with the cosmos that birthed you, a connection with those who looked at these same stars thousands of years ago, and with those who will look at them thousands of years from now. You are part of something bigger, something that cannot be grasped by the mind but can be felt by the heart. Earth is invisible on the scale of the universe. That's true. But on the scale of human experience, it is huge and beautiful. It is our home, the only home we have. And maybe awareness of our cosmic insignificance will help us take better care of it, better appreciate it, better understand how unique and fragile it is in the infinite void of space. We are alone in this corner of the universe. Or at least that's how it looks now. We have no evidence that someone else is looking at the stars and asking the same questions. Maybe we are the only ones, maybe not. But as long as we don't know, we must act as if we are the only ones, as if all responsibility for preserving consciousness in the universe lies with us. And if this is true, if we really are the only flashlight in the vast darkness, then our task is not to let this light go out, to preserve it, to pass it on to future generations, maybe one day to carry it to other stars, to make the universe a little less dark, a little less empty, a little less indifferent. This is a big responsibility for such small creatures as we are. But maybe that is exactly what our meaning is, not to be noticeable to the cosmos, but to notice it, to study it, to understand it, to admire it, and to carry the light of consciousness through the darkness and time. Our journey is coming to an end. We have gone from Earth to the edge of the observable universe. We saw stars, giants and black holes, galaxies and superclusters, dark matter and dark energy. We looked into the past as far as the cosmic microwave background. We asked questions to which there are as yet no answers, and we returned back to our small blue planet. Now you know what few know. You understand the scales. You realize your place. You see the whole picture, as far as is possible for the human mind. And this knowledge has changed you. Maybe imperceptibly, maybe deeply, but it has changed you. Stars will burn for billions of years after we are gone. Galaxies will spin, the universe will expand. And one day in the very distant future, yes, all stars will go out, all matter will decay, and the cosmos will plunge into eternal darkness and cold. This is the end that awaits everything that exists. Not today, not tomorrow, but someday. And you know what? That's okay. It's part of the story, our story, the story of the universe. Everything has a beginning and an end. We do too. But between these 2 points, there is now. There is this moment. There is you. And that is all that is needed. Close your eyes. Breathe calmly. Let your thoughts settle. You are on Earth. You are at home. You are part of space. You are invisible to the universe, but the universe is visible to you. And in this there is a strange beauty, a strange comfort, a strange peace. Good night, traveler. The stars will be waiting for you when you wake up. They are always there, distant, silent, beautiful, as a reminder of where we came from and where we might one day go. Until next time among the stars. Yeah.